All right, hey guys. Gonna go over lesson 6.6, which is mainly on right triangle similarities, or similarities in right triangles. Actually, I think it's the topic that it's called. Um, gonna do things a little differently now, so I'm just gonna focus more on just the homework module and the main concepts of each section, and then go over one or two examples and try to teach you guys the information ahead of time rather than waiting for you guys to ask me questions on things that you don't understand. So we're going to go over that. Um, so in this section, one of the biggest concepts is being able to take a right triangle and break it apart into three different smaller triangles. So right now I'm going to work on number 8, and it looks a little something like this. Where we have our variables, let's put them in a different color so that they stand out a little bit more. We got x over here, y, and we have 5, a length of 5 towards the bottom, and then this entire side over here has a length of 8. Okay, so with this section, what we want to do is focus on breaking this big large triangle where it looks confusing into 3 smaller triangles. So you should notice that there's one small triangle, one medium triangle, and then one large triangle. So the thing is, with all of these triangles, they're all similar triangles. So you can use your proportionalities to help you find out what x and y are. Okay, so I'm going to draw my little triangle. And generally it's a little obvious which side is the short side and which side is the longer leg. So I'm going to go ahead. The short leg doesn't actually have anything, so I'm just going to label the long leg X. And then when we go ahead and we draw our medium triangle, now we see that things kind of are changing a little bit. And what was our long side over here on the small triangle now becomes the short side of the medium triangle. So you'll notice that on the medium triangle I have the short leg and the hypotenuse. And then for the large triangle, I have the hypotenuse, which is 8, short leg, 5, and then the long leg as y. So, but on this problem, the cool part about this one is that I have 2 out of the 3 sides of a right triangle, which I know from previous learnings how to find that third side when I'm given 2 sides of a right triangle. We can use Pythagorean theorem. So we're going to go ahead and let's set that up using the Pythagorean theorem. This is my hypotenuse. So it's going to be set up as 5 squared plus y squared is equal to 8 squared. Okay. And if we go through that process, 25 plus y squared is equal to 64. We end up with y squared is equal to 39. And therefore y is equal to the square root of 39. So we know the value of this now. We know that y is equal to the square root of 39, square root of 39. So in order to find x, what we're doing is we are looking for, from these other triangles, I'm going to go ahead and I'm going to use this triangle. Here I have my hypotenuse and I have my short leg. So I want to look for another triangle from the other ones that have a hypotenuse and a short leg, so that I can go ahead and create my ratios. So let's go ahead and let's erase our work over here since space is a little limited. And I'm going to use large triangle and the medium triangle. Set of my proportions: hypotenuse, short leg, hypotenuse, short leg. So we go 8 over 5 is 2 hypotenuse square root of 39 over x. And from here we're going to go ahead and cross multiply and just kind of solve that way. So we get 8x is equal to 5 right at 39. And then we divide by 8. X is equal to 5 right at 39 over 8. So, not an extremely pretty number, but it is a number. Okay, and you can get a more precise value of it if you want by using your calculator. I'm good with that. That shows me that you understand the principles and not just can you use a calculator. Okay. So that was number 8, and I kind of wanted to go over that because we had to use the Pythagorean theorem to help us in solving some of the other figures. Anytime you're given a right triangle, you have 2 out of 3 sides, right away you use the Pythagorean theorem to help you out. Okay, it'll make things a whole lot easier for you. And that's usually what they look for. Sometimes they'll give you a hint telling you to do that exact same thing. Okay? So now we're going to move on to a slightly different problem. And we'll show you guys how to label things there. So let me go ahead and erase all of this. Now the problem I'm moving on to is going to be number 9. Okay. So let's go ahead and let's just draw this out really quickly. And we have A, B, C, 3, and 5. Okay. So that's the right triangle or right angle, so it's that one. So most of the time it's a little obvious to see which side is the long side, which side is the short side. Sometimes not so much. So like here it's a little harder to see which side is the long leg and which one is the short leg. Okay, so you do the best you can, and if you have to readjust later on after you figure out a value, then you have to readjust. So I'm going to draw my small triangle. Alright, so main thing is, the most obvious one is the hypotenuse with the value of A. And then short leg, long leg. This looks like it's the long leg. And then we'll readjust if we need to. Okay, so now medium triangle. See, it's a little bit larger. Sorry if you hear my kids in the background. So then this becomes, if it was the long leg here, you hear it, then on this one it's going to be the shorter leg. So C, 3, and 5. And I'm already noticing something, but I want to go through with it and then make any corrections. All right, so in the very large triangle, so the hypotenuse is the most obvious, and the way I'm going to label it is I'm going to add those two together. So that becomes B plus 3. Going to say that my long leg here is 5, and my short leg is A. So one thing that I noticed is kind of what we did in the last problem, where we have 2 out of the 3 sides of a right triangle. So I can tell that if I go through the process, I'll be able to find C. So that's one value less that I have to find. So we're going to go C squared plus 3 squared is equal to 5 squared. And so C squared is equal to 9, or C squared plus 9 is equal to 25. C squared is 16. C is 4. And that's important to realize and notice, is that C is 4. So why is that important to notice? Is because here I labeled C as the short side and 3 as the long side. Obviously, that's incorrect. So the value C still stands. I just have to make the adjustment, and I'm going to change this. I'm going to swap out those 2 places. So now C becomes 4, and this smaller leg becomes 3. And if I did it here, I have to switch these 2 around as well. So again, same thing. This long leg will be B, and then this shorter leg here will be 4. Okay? And now we can go ahead and we can go through. Everything else should be okay. Especially since this large one doesn't involve C, we're good. We don't have to worry about that one. So now it's about setting up proportions to help me find B and then A. And I'm going to use the triangle that is complete to keep on coming back to. So I'm not really going to focus on this large triangle whatsoever, actually. So since I have all 3 sides here in the medium triangle and all 3 variables here in the small triangle, that's what I'm going to focus on. So now I'm going to just set this up and let's solve for B. So I'm going to use B and my short leg, since I have my short leg here. I don't want to use B and A because then that gives me 2 variables and that doesn't help me solve. So we're going to go long leg over short leg, long leg over short leg. So B is to 4 as 4 is to 3. 3B is equal to 16. And so B is 16 thirds. And you can leave it like that if you want to convert it to a mixed number, 5 1/3. But now I know the value of B. And even though it's not the prettiest value, still a value. And we don't really care too much about it being a fraction or not, because when we go ahead and we solve for A, I don't need to use that side anymore. So now I can go through and I can solve for A using the hypotenuse and the short leg, since it came out to be a nice integer. You always want to go with the number that's a nice integer. So hypotenuse, short leg, hypotenuse, short leg. So same process. is to 4, as 5 is to 3. And cross multiply. 3a is equal to 20. Divide by 3a is 20 over 3. And that's kind of the biggest part about this, is being able to take the large triangle and break it up into 3 smaller triangles and set up your proportions that way. If you cannot see how to break up these triangles into the 3 separate ones, then I would recommend that you follow the instructions on 6.6 classwork, where it tells you to take an index card and cut it up. That process helps give you a tangible manipulative that you can use to help you make your 3 separate triangles. Okay, so that was pretty much the biggest concept behind 6.6, which is right triangle similarities, or similarities in right triangles. The biggest thing that, like I said, is 1, looking out for the Pythagorean theorem, and 2, being able to break these up into 3 separate similar triangles. Okay? So let me know if you guys have any questions. If anything else is bothering you, shoot me a message and I'll be happy to go ahead and work out those problems for you. All right, guys. Thank you.